All right, so we're going to look at the total surface area of a cone. So this is something I needed in order to solve a more difficult problem. So that's sort of the motivation here. But it's an interesting problem in itself. So let's see if we can look at the formula here and make some sense of it. So the total surface area of a cone is equal to pi r squared plus pi r L, where L is the slant height. So this pi r squared part shouldn't be too tricky, I don't think. If you know the area of a circle, then you would agree that that must be the area of that top part there. Pi r L is a bit more confusing. So let's have a think. What we're going to do is going to break our cone up into a net. So think back to maybe primary school where you made the net of objects. You would get sort of this top part would be this circle here. And then you've got what's called the lateral surface, which is sort of this sort of curved surface at the bottom here. And if you unfolded that, you would get something that looks like this. Okay, what we want to do next is we want to put some of those labels back onto our net. So I think you would agree the radius would be from here to here. It's the radius of that circle. This would be the lateral, this would be what's called the slant height. So that's this length here. And I encourage you to get out a piece of paper and construct this cone so that you can agree with me that that is the lateral, sorry, that is the slant height. But I've also got an animation here to sort of illustrate things a little bit. If we have our cone here, so we're talking about the curved surface area of the cone, then this length here is our slant height of our cone. And so when we unfold it, that's going to correspond to this part of our net. Okay, what we can say from there is, again, I think we know that the surface area, or the area of a circle is pi r squared. So we can call that A1. That's sort of our first area. So that's pi r squared. So that's this part. All right, the next part's a bit more interesting. What we're going to do is we're going to break this area up into lots of small triangles. And we're going to get something that's going to look like this. And what we're going to do is we're going to call the first triangle. We know the formula for the area of a triangle is a half times base times height. So let's call this first triangle a half times B1 times L. Now remember, L is this length here, right? This is the height of the triangle. Okay, and then what we can do is we can just keep doing that around the circle. So we're just breaking this what's sort of a sector of our circle into a half B1 times L, then a half B2 times L, half B3 times L. And as we make that smaller and smaller and smaller, you can see that adding all these areas up would give us a very good idea of the area of this lateral surface of the cone. So what we can do is we can say that, all right, the second area is going to be equal to half B1 times L plus a half B2 times L plus a half B3 times L, and so on to infinity, right? If we just keep doing that to infinity. But you'll notice that a half L is a common factor of all of this. So what we could do is we could take that out as a factor of the front, right? And then we're left with, well, B1 plus B2 plus B3 dot 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 forever, right? And then we just got to think about what the B1 plus B2 plus B3 equals. Now just think, remember, this is the slant height. So this distance from here all the way around must go around the edge of the circle, must go around this circle, right? If you're sort of constructing the cone. So this must be equal to the circumference of a circle, which is 2 pi r. So we actually get this, which is a really cool result. We get a half multiplied by L multiplied by 2 pi r. A half and the 2 cancel out, so you're left with pi r L as the surface area of this lateral part of the cone, the lateral surface area of this cone. And then so what we do for our answer is we add A1 to A2. So we get pi r squared plus pi RL as the total surface area of our cone. So I think that's a pretty interesting result. And maybe I'll just show you what happens. You can, if you take more and more triangles, we're getting very, very good approximations of the area. If we add all these triangles up, then yeah, it is the area of the lateral surface. So yeah, pretty cool technique there for finding the lateral surface and the total surface area of a cone. So good luck with all your studies, and I'll see you soon.